Let's be honest, the world is a heavy place right now. The economy, gravity, the existential weight of your own poor decisions, it's all dragging us down. So, I have a proposal, a global renovation project to lighten the mood. Currently, our atmosphere is 78% nitrogen. Nitrogen is boring. It's the chemically inert packing peanut of the periodic table. It just sits there taking up space, preventing things from catching on fire and generally being a buzzkill. So, let's get rid of it. Let's snap our fingers and replace every single molecule of diatomic nitrogen with an atom of helium. What happens? Do we simply float away into a utopian cloud city? Do we all talk like cartoon characters and laugh until we pass out? Well, yes. But then the birds fall out of the sky, the water boils instantly, and you freeze to death while screaming in a pitch so high only your dog can hear your final regrets. Let's run the numbers. First, we need to understand what you are currently breathing. Take a deep breath. That was mostly nitrogen. Nitrogen is heavy. It has a molar mass of about 28 grams per mole. It gives our atmosphere heft. It gives it density. It pushes down on your shoulders with the weight of a Honda Civic per square meter, which keeps your blood liquid and your ears from popping. Helium, on the other hand, is a noble gas, and like most nobility, it is flighty detached and essentially useless for manual labor. It has a molar mass of only 4 grams per mole. If we swap them out 1 to 1, maintaining the same number of particles to keep the pressure roughly comparable, as at least for a few minutes, we have fundamentally altered the fluid dynamics of the entire planet. So the switch is flipped, nitrogen is gone, helium is here. Welcome to Earth 2.0, the squeaky. The first thing you notice isn't the cold or the dying engines, it's the noise. You turn to your friend Steve to ask if he feels lightheaded. Steve opens his mouth, and out comes the sound of a terrifyingly panicked chipmunk. Here is the physics of why you sound ridiculous. Many people think helium changes the pitch of your vocal cord. It doesn't. Your vocal cords are vibrating at the same frequency, but your throat, mouth, and nasal cavity act as a resonator, like the body of a guitar. Because helium is so much lighter than nitrogen, sound travels through it much faster. In air, sound moves at about 343 meters per second. In pure helium, it's nearly 972 meters per second. This is almost Mach 3 for regular air. Because the wave speed is higher, the resonant frequencies of your vocal tract shift upward. These are called formants. Essentially, the bass in your voice is deleted, and the treble is maxed out. So now, the entire planet sounds like a Saturday morning cartoon. The panic in the streets sounds less like a disaster movie and more like a sped-up recording of a kazoo convention. It is hilarious, briefly. While you are laughing at Steve's squeaky screams, look up. You know how birds fly. They rely on lift. Lift is generated in part by the density of the air flowing over a wing. The equation for lift contains a very important variable ρ, representing air density. Nitrogen is dense, helium is not. By swapping them, we have dropped the atmospheric density by a factor of about 7. This is a problem for anything relying on aerodynamics. A pigeon flapping its wings in a helium atmosphere produces about as much lift as a fish trying to swim in a bucket of steam. It's not enough. Every bird in the sky immediately stalls. They flap frantically, looking like vibrating specks of panic, before plummeting to the ground with terminal velocity. But it's not just birds, it's 747. Planes are heavy. They need thick, soapy nitrogen air to hold them up. In helium, the wings are effectively slicing through nothing. The lift coefficient vanishes. Every aircraft currently in flight becomes a heavy, metal brick. And here's the kicker: parachutes won't work either. A parachute works by drag, air resistant. Drag also depends on air density. In this thin, wispy helium mix, opening a parachute would be like trying to slow your fall with a napkin. You would hit the ground doing a solid 150 miles per hour, so the sky is raining birds and Boeing, but at least you feel light on your feet, right? Let's address the visual hook. You might think, helium floats, so if I'm in helium I'll float. Wrong. Physics is cruel, and it hates your dreams. Buoyancy works by Archimedes' principle. You are buoyed up by a force equal to the weight of the fluid you displace. Since we made the air lighter, the weight of the fluid you displace is now tiny. In a nitrogen atmosphere, the air supports a tiny fraction of your weight, about 0.1%. In a helium atmosphere, that support drops to almost zero. You actually become heavier on the bathroom scale. You don't float, you sink faster. However, if you are holding a balloon filled with regular old nitrogen air, that balloon is now heavy. It falls to the floor like a stone. A child crying because their lead heavy balloon crushed their toes is a very specific type of tragedy that only physics can provide. Now, the real killer. The reason you don't live past the first 10 minutes, it's not the lack of oxygen. We kept the 21% oxygen, remember, you can breathe. Deep sea divers breathe a mixture of helium and oxygen called heliox to avoid nitrogen narcosis. So, biologically, your lungs work. But there is a reason divers wear heated suits. Helium has a very high specific heat capacity, but more importantly, it has incredibly high thermal conductivity. It is a heat thief. It is 5 to 6 times more conductive than air. Normally, your body warms up a thin layer of nitrogen around your skin, creating a little cozy blanket of insulation. Helium looks at that blanket and laughs. It strips the heat away from your body faster than you can generate it. Standing in a room at 70 degrees Fahrenheit, 21 degrees Celsius, in a helium atmosphere feels like standing naked in a freezing wind. Your body heat dumps into the air instantly. Hypothermia sets in within minutes. You start shivering violently. Your core temperature plummets. But remember, when you try to scream for a blanket, you sound like a squeaky toy. This applies to the planet too. Nitrogen is a decent thermal buffer. Helium is not. While helium isn't a greenhouse gas, the way it redistributes heat is chaotic. The night side of Earth would freeze rapidly. The day side would scorch. Engines would overheat because their cooling systems are calibrated for air that holds heat differently. And then there's the final escape. This is the big deal that we are going to minimize just for fun. Gravity holds our atmosphere down, but gas molecules are always moving. Their speed depends on their temperature and their mass. Lighter molecules move faster. Nitrogen is a slow, lethargic molecule. It's too heavy to escape Earth's gravity. It stays put. Helium is essentially a cracked-out squirrel. At standard temperatures, helium atoms move incredibly fast. In the upper atmosphere, known as the exosphere, the helium atoms pick up enough speed from solar radiation to reach escape velocity, about 11 kilometers per second. This process is called Jean's escape. Without the heavy nitrogen lid to keep things contained, our new helium atmosphere begins to leak into space. It bleeds away, slowly at first, and then faster as the pressure drops. As the atmosphere thins, the pressure at sea level drops. Once the pressure drops below the Armstrong limit, about 6% of standard atmospheric pressure, water boils at body temperature. That means the saliva on your tongue, the fluid in your eyes, and the water in your lungs begins to boil. Not hot boiling, just turning into gas because there is no pressure to keep it liquid. You would dry, freeze, and suffocate simultaneously. But, honestly, you'd be dead from the hypothermia way before the atmosphere floated away. So the space vacuum death is really just a bonus feature for the cockroaches. So let's recap our experiment. We replaced nitrogen with helium to lighten the mood. The result, global communication devolves into high-pitched screeching. Every aircraft and bird falls out of the sky, destroying infrastructure. Heat is stripped from your body so fast you freeze to death in your living room. The atmosphere eventually gets bored of Earth and leaves for the vacuum of space. But for a brief, glorious moment, everyone sounded really funny. And isn't that worth the extinction of the human race? No, it is not. Put the nitrogen back. Thanks for watching. If you want to help me buy a heated space suit for the inevitable atmospheric collapse, consider subscribing. And remember, physics doesn't care if you're having fun. It only cares about equilibrium. Good night.